Number 7 says, given f of x equals negative x to the fifth plus 9x cubed, find the following information and graph. This polynomial can be factored using methods from intermediate algebra, which means you do not need to use synthetic division, don't need to find the possible rational roots, you just need to factor it like you factored in previous classes. So let's factor first. It looks like I have a GCF of negative x cubed. I take a negative out because I always take out a negative if the first term is negative. And then the highest exponent I can pull out of both is x cubed. Negative x to the fifth divided by negative x cubed is positive x squared. Positive 9x cubed divided by negative. A positive divided by negative is negative. X cubed divided by x cubed is just 1. So we have just the negative 9 left. We don't have any x's on that one. Now negative x cubed does our GCF, but x squared minus 9 is a difference of squares. So that's x plus 3, x minus 3. So this is my factored polynomial. F of x equals negative x cubed, x plus 3, x minus 3. Okay, so my degree from my original problem is 5. My leading coefficient is negative 1. Because 5 is odd and my leading coefficient is negative, that means I'm going up and down for my end behavior. The zeros, I'm going to have a 0 of 0. If I set negative x cubed equal to 0, really that's 3 copies of x equals 0, so that's multiplicity of 3. And then if I set the other ones equal to 0, I'm getting x equals negative 3 and x equals positive 3. You don't really need to show all that work, just being a little bit thorough for the review. Take your zeros and make them into x-intercepts by putting them in ordered pairs, 3, 0, 0, 0, and negative 3, 0. You can plot those as well. And my y-intercept, we find the y-intercept by evaluating f of 0. So that gets me negative 0 to the fifth plus 9 times 0 cubed, which is 0 plus 9 times 0, which is 0 plus 0, or just 0. So one giveaway, if you ever have an x-intercept as a 0, 0, then the y-intercept will also be 0, 0, because the origin is kind of special that way in that it's the only point that is both an x-intercept and a y-intercept at the same time. So if you have 0, 0, the origin to be either the x or the y, it must also be the other one. Similarly, if you don't have 0, 0 as an x-intercept, then it can't be 0, 0 can't be a y-intercept. So here we go. We have all the points we have. So I know my end behavior is up to the left and down to the right. Going through my first point at negative 3, I don't have any interesting multiplicities, so that means I just go straight through. I have to turn around at some point. We don't actually know exactly where we turn around, not until you get to calculus. And then at 0, I have multiplicity 3, which means I go through with a wiggle. When I go through with a wiggle, one easy way to graph this, because I have a lot of students have a hard time graphing this. If you just put like a little flat line right there, and then you connect them, that's how you can get a wiggle. There's truly not a flat slope there. There's not a flat line at all, but it might just help you to graph it a little bit easier. Then at some point you have to turn around, go through 3. 3 is multiplicity of 1, so that means you just go straight through. Oh, we gotta tag it. And it connects with my end behavior going down. So that is my graph. Our next problem, number 8, is probably the longest problem of the whole test. We have all of the parts. You have the possible rational zeros, you have the synthetic division. All of that is a piece of the answer here. So don't get too overwhelmed. Just go line by line, getting as many points as possible along the way. My degree is 4, because that's the exponent, the highest exponent. The leading coefficient is 2. Because my degree is even and my leading coefficient is positive, that tells me up and up. the possible rational zeros. I get those possible rational zeros by taking the factors of my constant term, 8, over the factors of my leading coefficient, which is 2. The factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. The factors of 2 are plus or minus 1 and plus or minus 2. So I need to go through and evaluate each one. 1 over 1, that's going to be plus or minus 1. 2 over 1 is going to be plus or minus 2. 4 over 1 is plus or minus 4. 8 over 1 is plus or minus 8. So I've done over 1. Now I've got to do over 2. 1 over 2, that's plus or minus 1 half. 2 over 2, well, that reduces to 1. 4 over 2, that reduces to 2. Again, 1 and 2 I already have, so I don't need to rewrite it. 8 over 2 reduces to 4. Again, I already have it, so I now have gone through all of the factors of plus or minus 1, divided by plus or minus 1, and divided by plus or minus 2. At this point, to get the zeros, I need to factor, and I need to factor a lot. Okay, so because my exponent here is 4, that means I need to factor 2 zeros out before I get down to quadratic. Because if I get 1, then that takes me down to cubic. I get another, that takes me down to quadratic. Once I get down to quadratic, I can use quadratic formula or factoring or any other method I can get. But because I start with 4, I need to get down to 2. So what I'm going to do is I'm going to use the space here below, and I need to guess a possible rational zero. So I don't know which one to pick, so I'm going to go ahead and pick something easy like 1. So I'm going to do 2, drop the 2, multiply, add down, multiply, add down, multiply, add down, negative 8. And look at that. Accidentally, I got it right on the first try. So because this is correct, because I have a 0, I know 1 is a 0, which means the factored polynomial is going to have x minus 1 in it. Now I am going to synthetically divide again because now this is cubic, right? So this would be like 2x cubed minus 3x squared. I still can't figure out cubes, okay? I can't figure that out. So what I need to do is I need to take those numbers. Notice I took the answer numbers, not the original numbers. I'm going to take the answer numbers and try another number. Often I like to try the same number again just in case I get a double root. I might get one, so I'm going to go ahead and try it just to make sure I don't have two copies of one as a 0, and I don't think this is not working out. Okay, so there's only one copy of x minus 1, so let's go ahead and use those same numbers: 2, negative 3, negative 18, and negative 8. And I need to pick another number to put in my box. Again, I don't know what numbers to pick, but I am going to only pick numbers in my list of possible rational zeros. So I've used 1. I could try negative 1. So when I drop this down, 2 times negative 1 is negative 2, add down is negative 5. Negative 5 times negative 1 is positive 5, add down, that's negative 13. Negative 13 times 1 is 13. This is not going to be 0. Okay, so that one doesn't work. All right. So let's try another one. Negative 3, negative 18. So notice that as I'm going along, I cross off the ones that don't work. That's not helpful to keep them. You can erase them if you want, but at least cross them off so that you know that that wasn't helpful. Let's see. Let's try 2. So 2 times 2 is 4, add down 1. 1 times 2 is 2, add down negative 16. Oh, this is not going to work. That's not going to get me 0. How about negative 2? Two times negative 2 is negative 4, add down is negative 7. Negative 7 times 2 is 14. Positive. Add down, that's negative 4. Negative 4 times negative 2 is positive 8. Oh, it should be negative 8. I dropped a negative right here. And negative 8 plus 8 is 0. Yay! Hooray. Okay, finally. So this is my next one that I guessed that I got correct. So the other factor would be x plus 2. And then what do I have left? 2x squared minus 7x minus 4. So I need to factor that. So let's see if I put the 4 here. One and 4. That's 8 and 1, with a negative on the 8 and a positive on the 1. So I'm getting 2x plus 1 and x minus 4. So those are your other two factors. Okay, so I'm going to scroll up so I can do the rest of the problems here. So my zeros are positive 1, negative 2. If you set this 2x plus 1 equal to 0 and solve, that's negative 1/2 and positive 4. Turn all of those zeros into x-intercepts. And we can plot them. The y-intercept we find by evaluating f of 0. Notice that each one of these factors multiplies out to 0 because each of them have a multiplier of 0 in it. So I have 0 plus 0 plus 0. That's not 10, that's a 0. Minus 0, minus 8, plus 8, plus 8 equals 8. So if I plug in 0, I get out 8, which is just the constant term. Okay, so my end behavior was up and up. None of these have any multiplicity, which means I just have to go through and touch each of my x-intercepts and y-intercepts. There's nothing else, no bounces or wiggles, just go straight through, and through. And that finishes up this page.